So hi everybody and welcome back. This is our C++ tutorial series for absolute beginners. This is video 222, and in this video we continue with our exercise. And I said in my last video that we are almost finished, but it looks only like that we are finished because there are still many errors in it. Some of them I will show you now, and we stopped here at 21 and let's go to 22. And 22 is, like you can see, I have here a if check. This one is just to prevent a possible error. It's not a direct error, which means you can see, let me copy this first. Step 22, copy here and put it on the while loop on top. And I already mentioned that the order where you put the conditions are very important as well. Because if you put it, for example, on the bottom and it checks later, it makes no sense. It must, most time this error checking must come first and then the regular code. But let's see what this error here is. So here I say in step 22, first of all, this here is also a very interesting if statement. Why is this so interesting? First of all, you can see we have here a AND. AND is a logical operator. We compare here. Now, both sides must be true. And both sides use this ampersand, which means we negate the outcome. And here I use a pointer. And the pointer, I wrote it here on top, is implicitly converted to a bool in a if condition. That's why I can use here a pointer. The next thing is, it's a little bit hard what I did here. It looks very simple, but it is the, let's say, you have to think one step more to understand it a little bit right. First of all, again, here we have an AND, and both sides must be true. But I use here a pointer, which is converted to bool, which means if this pointer has not a null value, then it will be true. And here I use an ampersand, which means this one must be false, then this one makes it true, this one here the same, this pointer must be false, this make it true, then both becomes true, and then we can enter this body. You see, it's a little bit complicated, think about this, but sometimes you need the opposite to show something. And you can see here in step 23, if this is the case, I wrote here a little comment. It's not perfect, but it says here pointer must be set at this point, which means this both pointers here, which I create, and in my diagram you can see these are this comparison pointers here. They must be set because if they are not set, then I can't compare. And if I can't compare, it's an error probably. And that's why I have here a throw error here. And the next point is, I'm not sure if this one is, here you realize that probably that what I did here is not absolute right. Because we will see that this one is not right. Let's say absolute right, or let's say so. There is something missing. You will see I have here a else if because I have not covered that step, but let's go here step by step. So here 23, that was 23. Let's go to 24. Let's see the next problem. Yes, that was the problem which I already told you. That was my pointer here, and that was this this comparison operator. That was this pointer where I said, I think I started here with, yes, if this one is bigger than the second one, then swap, right? That was here my initial sort algorithm. And the problem was, I need here the less sign. And you see that was not a compiler error, that was a logical error, because that was here the task. That this kind of error I already explained you here. We want the biggest number on top and not the lowest number. And I was lucky actually. Why I was lucky? Because I needed only to change in my code here this little comparison operator. Sometimes it's not so easy. Most times it's not so easy, because most times if you already made something from start wrong, then you set probably more things wrong in your code. But in this case, like I said, lucky, we could just change this one and all worked fine. All right, that was 24. Here it's already in. So this 24 step was already there. Let's go here to 25, the next problem. And this one is interesting that this one showed not there. 25, it says I need a break here. And this one is a very interesting error, because this error should be shown here. It's not there. Let's see. So let's me mark all. Let's comment this one here, and let's try this code here again. Let's save this, because normally it should throw or make an error. I don't know why it's working. In my last code it was not working, or I made there something wrong, but here it looks normal, it looks right, but I don't know why. That's not so important. In this code anyway, it was not working, and the reason was that here I need, like I said here, where is that? Not here. Here. The reason was, after this setting here, I need here a stop. That was this special condition. That was here the condition when both the loop and position pointer, that was this one, this end position pointer, and the swap pointer second condition, this here, are pointing on the same node, which means I indicating the endpoint, and after the endpoint, okay, reset. And that's why I need this here break. That was also a mistake. Let's put this in. And very important again, in the right place, of course, because we have here loop end position pointer and swap end position pointer, so I must put it here. Okay, that was this. And let's see, 26. What have we have here? There is no 26. I'll have to go up a little bit probably. Now 26. Yes, there is 26. And 26 is the thing what I mentioned before, that it is not perfect what I made there, because we need a else if check. And this else if check is this one. Let's copy this one. Because here, what I showed you here, that I said before, the two pointers must be set at this point, right? And I put this if statement on top. This is the first thing after my while loop, which will be checked first. If both are not set, it will throw an error. And error means, again, I have in my try catch block, what I showed you last video, an error message here. It goes here to the catch with an integer, and then the integer I interpret it like I want. In my case, I said C77 is that here, what I wrote here down. And the thing here is, what happens if one of this one is true and the other one is false, which can happen. And that's the point here. Let me paste this one here first. So you can see there is a state, or I say state, a possibility that one of this pointer is true and one of this pointer is false. Let me show you this one. So for example, when we go here down, or let's make here one more node, and let's say 50 here. So you can see at this point here, one could be, the first one will be set, and the second one is not set. So the one pointer is true, that would be true, and that would be false. Because at this point, this pointer, the second one, will stay like null Peter, right? And this I mean that you have checked many conditions here. For example, that was the normal condition. You have here enough nodes where you can set all things nicely. Here you have only 2 nodes where you have set immediately the end pointer. Here you have perhaps only 1 node. Then the second one is automatically null PTR. This condition you have to check. Perhaps you have even no node at all, so there is nothing. And then you have to check this condition as well. So in this case, I catch this condition. You can see this else if stays here. Again, the same logic like before. If one of this one is false, which becomes true, and I use here what is that? That is the OR operator, which means compared to this one, both sides must be true. Here, only one of this must be true, right? And then I said, if one of this one is false, then it becomes true, then we can enter this block. Interesting is, of course, both sides can't be here true. Why not? Because I already catch both sides here on top. So only one of this side can be true. I mean false, and then it will enter here. If both sides are true, becomes false, which will enter not this body here. Then it will not enter this part here as well, which means both pointers were set. That is the normal condition, so this whole block would be skipped. Okay, let's see what I do then. If one of them was false, which means this condition here, one here, this second one is here false. There was only just one node. Then I said, okay, check if this if the first position pointer was a null PTR, which is possible. And then I say break. And interesting here is, again, I use the break keyword. We learned this break will break if you are using in a while loop. I'm using in a while loop, which means if you are using it here, it will break this while loop, and yeah, you are going out of this while loop. And the same thing we do with the second position pointer. In this case, the second position pointer is indeed null PTR. And null PTR, like I said here before, will convert it again implicitly to a Boolean. Boolean means becomes true or false. Here it becomes false, but I use here this negation again. This ampersand becomes true, which means this enters indeed here this body. And that would be here the second position pointer is in this case true. Here I make again a normal comparison equal to null PTR. Yes, it is null PTR, and it will break. All right, and here I showed you something interesting as well, and I want to try this with a ternary operator. What was this ternary operator? Do you remember this one? Uncomment. It was this operator where you can just it's an if statement, a short if statement if you want. Similar to short if the first one is true, then if this first expression here is true, then it becomes this one, else it would become this one. But in this case it is not working. That's why I have commented out, but I wanted to show you that it's not working, and I wanted to repeat again a ternary operator. Ternary operators are most time used if it's possible. In this case actually was not possible. Okay. And then, which step was that? That was 26. We are almost finished. But still, there are many bugs in 27. Let's jump there. I have to go up a little bit. Let's try it again. 27. Oops. Yeah. 27 again. It is again check. Let's see what I'm checking here. 27, let's copy this one. It is here in void over the while loop. Okay, go here. The null PTR is here. Let's go here and see what 27 is. And you can see 27 is again a check. Again, anything I have to check here. All right, here I set a comment. I need to check first if head linked list is null PTR and retreated. All right, this is 29. We watch this later, but here in 27, I check if this one is a null PTR. Yes, I think that that's this step here. No, this is just setting the swap pointer position to head, and then I check. Why I have this both here? Or did I something wrong? No, it's all right. So here, swap pointer first position, that is this one here. I set to the head of linked list, which means here at start. And then I check if head of linked list param, which is that argument which we get, if this is a null PTR. So with other words, you can read here what I wrote. I check if this is just, if I have already a list here, which means if this is already a null pointer, null PTR, the first one. So there was no list that was, I think that's the condition with no node, right? So here there is no node. And if there is no node, then we can't check anything. And here I say if there is a node, you can see again the head linked list param not equal. Not equal means there is something to null PTR. So if the head has indeed something there, so in this case the head would have nothing, that would be null PTR. That would means here this one would become false. It will not enter this place. It will enter this else state, and else would throw here an arrow. And you can see here I use an arrow. This is already the next one, 28. Another error code 666 I wrote, and that was again my own definition. And what I did here is just again where I showed you that the whole thing is in a try catch block, and I can catch here an error code, and error code means just an integer which is which I can define. And here here you can see it's only catch 77, whereas the 666, the point is I can define 666. And how I did this, very simple. I just added another if statement. So because this try catch block, you can see the try catch block with this error code is just an argument, and I can use it like all normal arguments, right? And here I said, okay, if the error code, which is this one here, is 666 equal to 666, then use this message here. So you can see I have here a different message, and let's read this message. It should give now an information about this error. It says head of linked list param pointer to next node. That is this, whoops, not this one. That is that what I showed you, this head here. Head of linked list param is null PTR. So which means this one is null PTR because there is no node. That must be, there must be a node, then it would be not a null PTR. But there is no node, that's why it is a null PTR. And that's why I print this out. Calling for null PTR is not allowed. That was again my random text. Return value, it is not succeeded. This -1 means just it is not succeeded. And you can see return 0 here in main means the program ended normally. Return -1, the program ended not normally. The programmer should check this. And again, this error code you should write normally in a log file with more information, because this is to less perhaps file where the error occurs, on which line, when this error occurs, into more description and all this kind of stuff. But this is just that a repetition. We will talk about this try catch blocks later. That was 28. So let's go here on 28 here again. Let me find this one, and I think we are almost finished. Right, let's see, 28 steps here. I have even one more, I think there is one more step. 29 and 29, yes. Okay, why I have here something like this. Let's check for null PTR. Okay. I included this already, so I see what I did here. The point what I did here is, let's go back to 28. It was the 28. So okay, 29. here. So this line here, step 29, means just a check. So this here, this line here, I have again surrounded with a if block. If block means all time you check something, and in my case I checked if this line here is not a null PTR, because here it should be a null PTR, and actually I checked it here with this condition. If this is not a null PTR, if this is not a null PTR, if it's not a null PTR, then it will, if it's it will do this one, and if it's a null PTR, it will throw an error. Right, that was just this if check again, what I mentioned here again. We have many conditions you can check with a if, very easy, and you have to do this. And in my code, I finished now. I stopped here. There are many other errors, but there's many other errors I want to show you now with a flowchart in the next video. And I told you already to follow my explanations here. It's very hard, but the flowchart will make your life easier. And the best part is a flowchart. It's very easy. The basic flowchart, it's very easy to make, and that's a very good benefit. But at this point, my code is finished, which means it produces indeed this outcome, but I will still find some errors. We will see them later. But when I start now this code here again, this should work. Important is you must now checks normally, many checks. Actually, my code is not working. Let's see. Okay, I have, like I said, when you have here, open up another file where main is there and the same names are there, can cause problems. So mark the I have to mark this, comment this one. We will talk about this one when we learn the file system here, CPP files, header files, and all this kind. Why this errors what you see happens here. It's exactly this, but now I can run it. It should work now. Yes, it starts again. My login. Go there, and this is the outcome. It looks similar like before, but like I said, this one we catch now in this steps what I showed you right now, many situations. For example, what happens if there is no linked list? We can test this. Let's uncomment, let's comment this one. Now I have no linked list, and let's start. This situation should be catched. Let's see if this is indeed catched. No, it's not. You see, that was bad. It is not catched. And why is this not catched? You see, there is an error again, but let me see why. And the reason for that is, I see it already. I think I have made this here, but not showed there. Oh no. Okay. Uncomment. Let me see this one again. I think there was one more step which I have not made. Yes, I see. Oh, 27. Okay, 27 was actually one more step. So yeah, I jumped here to 27, but here I have not changed it. So you can see in my other code here, I changed at 27 the other step 2 and step 3, and in this case I have here step 2 and step 3, and 3 not changed. So let's watch 27, this step 27 again, why I did this. Forgot this one here, and that's why all this happened. So here I added this one here. So let's see what I did here. Actually is, you can see I created here a node pointer, and interesting is in step 2 you can see the code in step 2 is exactly the same in step 27. And when we watch the code in step 3, I can see the only thing which I changed was that I added, instead creating a null PTR, I just created a node and assigned it at the same time, because I know what I want to assign. I want to assign this one here to this one here. But in step 27, I make it back. So I set it back to the step 2, and there is a reason why I did this. And the reason is, let's comment this out. comment. The reason is again this check here, because I want check. Let's see, 27. Yeah, null PTR check is because here is possible that this one here is a null PTR. Wait a second. Okay, the check is here. When I have here a null PTR, you can see it here, and the head of linked list was also a null PTR. Then I can check here against a null PTR. That looks a little bit strange, but that's the reason why I made this. Because if this one here is set like I set it here, not to a null PTR, and you can see the head or the swap first position pointer, it's not a null PTR because I already set it to something, and then I can't check it to null PTR, right? Because here would be already the error, and you saw it already in my code before. There was an error because this one could cause a problem, and now I make this check. That can be not a problem. Okay, I hope you see it. It's a little bit strange that I need all the steps, but the reason for that is just that I check against null PTR, and if I have here this setting, I can't check against null PTR. That was the reason. So let's try again, and we are finished with the comment this one. We are finished with the code. There are still many errors, and let's see. Let's run this again. So this time, and you can see here the case where I have no list is anyhow catched. And how I see that it's catched, you can see we have here an error code. Error head of linked list param, and I showed here pointer to next node. Node of linked list param is null PTR, and calling from null pointer is not allowed. And you can see that was this error code what I showed you here when that was one condition. Where is that again? There is the one condition when there is no list, and I said if there is no list, there should be an error because we expect this as a list. But of course, interesting is here, if there is no list, you can catch this in a better way as well. What I mean in a better way, you can say, okay, there is no list. Then you say, for example, call again the function with a list. It's possible, so you don't have to stop the program. This is just, I want to show you how to use this error code, but normally this kind of error is not a hard error, which means the program is broken. The program just indicates here is no list. I can't work, for example, with this error. Then we can check here one more state. Let's say what happens uncomment if there is only, oops, other way around. Comment if there is just one, let's say there is just one uncomment, just one entry, right? Just one entry. You have really find all conditions, and this is a bigger problem than writing the code, I think, to write all to find all conditions. You can see now I have just one entry, and this is again a special condition which I showed you before. What happens if there is only one entry? That was this condition. So you can see this one must be catched too. And all these special cases, you have to find every case, every possible case, and this is actually harder than to write the code, because if you find not every case, there is probably a bug. And with that said, I won't stop here and show you in the next video with a flowchart. I hope you learned it by now, how to understand this code in a more easy way and to find probably more bugs in it, because the flowchart shows just the flow, how the code should work. And we will check also, yeah, situation. But there is one more thing. I mentioned this one also in some videos ago. There is a states And careful about states. They treat states too theoretical. We need states more practical, which means what I showed you right now, we have now to find every state means here in our case every possibility how the code can be, like normal use case, there is no list use case, there is only one entry, or anything what can happen we have to catch. And this all possibilities are noted at as a one state, and one state means then you have to react from this point on how the code will continue. We will talk about this more, but not in the next video. In the next video, we talk about flowcharts. So with that said, if you have any questions and any comments like all time, write it in the comment section. See you in the next video where we start with the flowchart. Bye, good luck, and like all time, never give up, have fun.